Okay, so Chapter 3, Section 4. Oh, there's our first page. It is not doing, it has lost the pointer options thing on me here. Just a minute. Okay, so transformations of functions. So what we're going to do with that is we're going to take basic functions, and by that I mean those same basic functions that we listed in the previous section, and we're going to modify them in certain ways. Okay? So the first type of modification we're going to talk about is vertical shifts. What happens with that is you take a basic function of some kind, and you add a number to it, or you subtract a number from it, and you'll notice that the plus and minus c are both outside the function, right? They're not in the f of x, they're outside it. So down here, so the basic function for this one is f equals absolute value of x, right? And then when we add 3 to it, that's this one here, look what happens. We shift it up 1, 2, 3. Otherwise, it's exactly the same function. The other option down here, we're going to subtract 3 from it, and it shifts it down 1, 2, 3. Otherwise, it's the same function, right? If we'd added 4, it would have shifted it up 4. Okay? So, when you add or subtract a number outside the function, it takes the original function and just shifts it up and down. It's what we are calling a vertical shift. For a horizontal shift is the next kind we're going to talk about here. Now notice the difference. See, we're going to add c, we're going to subtract c, but it's inside the function. Now the thing about this one, because the way it works is the horizontal one works maybe a little kind of backwards from the way you might think. If you add a positive number, like if we look over here, we added 3 here, right? So we have plus 3 inside. It actually moves it 3 to the left. 1, 2, 3. Over here, if we subtract 3 from the inside, it moved it 1, 2, 3 to the right. So that's a horizontal. All right. So the vertical ones, if you add or subtract something outside the function, the horizontal inside the function. Okay. And then you have to remember for the horizontal, if you add a positive, if you add something, it moves it to the left. If you subtract something, it moves it to the right. All right. Next type of modification is going to be a reflection. So for a reflection, you just put a minus sign on it in front, like right there. Okay. So for example, so the purple one is our original function here. Okay. All right. And when we put a minus sign on it in front, it literally flips it across the x-axis. So here's the new one down here, and you'll see the red one is it's like a mirror image. It's like if you put a mirror right there across the x-axis, it's like it's just reflected right across there. All right. So if you put a minus in front of the function, that's what you get. You get a mirror image across the x-axis. It's a vertical flip. You see that? Anything you do outside the function is going to have a vertical effect. Okay? So this one flips it vertically when I put the minus sign outside the function. And so we're going to page through a little bit of what happens with this one. So let's start with this function, y equals x squared. There's the basic y equals x squared function. Now if we put a minus in front, what's going to happen is it's just going to reflect it across the x-axis here, okay? So we're going to see the same thing, but the u is going to be kind of like this. See? All right. This would work this way for any function, okay? Now here we're going to do both. We're going to do minus 2 inside, and if you remember, minus inside is horizontal, 2 to the right, and minus 1 outside, that's going to be 1 down. So we're going to take our basic absolute value function here and move it 2 to the right and 1 down. Okay, there's the basic absolute, remember the standard basic absolute value, whoop, I can't draw very well with this thing. It would have been a V like that, right? And so we moved it 2 to the right and 1 down. Now this one is going to be that same thing again, but with a minus in front. Okay? So what do you think is going to happen? And what the minus in front does? It's a vertical reflection. Okay, right? You see it's the same thing, but with a minus outside. Now notice the parentheses around this whole thing. Okay, you put the parentheses around the whole thing. You flip the whole thing, you're just going to be a vertical reflection straight down. Okay. Well, okay. You see it moved, here we were, the vertex was at a minus 1y, and now it's at a plus 1y. That's because this minus, it's because they put the parentheses in here, this minus then affects the minus there and turns it into a plus. Usually when they do these, they don't put the parentheses around it, you just get the minus out front, and it would have taken the same thing and flipped it. All right. Now, the other thing is, you notice this time it's a minus inside the function. Okay? Anything you do inside the function has a horizontal effect. Just like adding and subtracting inside shifts it left and right. Well, when you put a minus inside like this, right, you know, like this right here, right, and like here, what happens then is it flips it horizontally across the y-axis. So if the purple one over here is the original, right, put the minus in the middle, and you get the red one, right? You get this red one. Okay. All right, so here's our original function over here. We're going to start with, here we're going to start with shifted 2 to the right, okay? And then we are going to apply the minus x to it like this. Okay, so what is that going to do? It's going to reflect it horizontally. Okay. It's just a mirror image across the y-axis from the original. That's what the minus did. So, now the last topic is vertical stretches and compressions. Actually, no, we're going to do horizontal stretches and compressions as well. And for that, if you multiply by a number outside, okay, it's either going to stretch it or compress it. If the number you multiply by is bigger than 1, it stretches it vertically. And if it's between 0 and 1, it compresses it. So you'll see, like, see here the purple one, right? The purple one is the original, x squared. If you multiply it by 3, since 3 is bigger than 1, that stretches it up. All right, it kind of stretches it up. If you multiply by a fifth down here, see that's between 0 and 1, it pushes it down. That's what they're calling compression. Okay? And we'll use one of those then to graph. So actually, here's a nice thing too. You can do this for individual points. So the original is x cubed. We're going to make it 2x cubed, right? So on the graph of x cubed, it is the point 1, 1. If x is 1, y is 1. But if it's 2x cubed, then if x is 1, y is 2. 0, 0 doesn't move, right? Because 3 times 0 is 0. And then 2, 8, we're multiplying the y by 2 when we do this, so 2, 8 becomes 216. And you graph it, and you'll see it's a little bit subtle with the size range they picked here. On this one, you have 1, 1 right here, right? Here we have 1, 2. You had minus, where's my cursor? Here on the same token, you have minus 1, minus 1. Here we have minus 1, minus 2. And on this new one, 2, you can see it's nowhere close to it, because 2 would be 16. It'd be like 216 would be way up here somewhere. 1/2 then. So you multiply y by a half, and 1, 1 becomes 1, comma 1/2. A half times 0 is still 0, so 0, 0 doesn't move. And 2, 8 becomes 2, 4, because a half of 8 is 4. And this time you'll see over here, So at 1 you have 1 and then a half, and at 2 you have 2, actually 4, and then the same thing happens at -1 and -2. All right. Now there's horizontal ones too, and just like everything else, anything you do inside the function, you see that you multiply by a number inside. When you do it inside the function, you have a horizontal effect. And again, it's kind of backwards. If you multiply by a number between a and, if a is bigger than 1, it compresses it. All right. If a is between 0 and 1, it stretches it out. Okay, so all the changes inside kind of go backwards. All right, so let's have a look here. So here's square root of x, and here's the original. All right, so if we're going to multiply the x by 2, then what happens here? So if x is 1/2, right, just take a 1. If x then is a half, if I stick 1/2 in here, 2 times a half is 1. The square root of 1 is 1. 2 times 0 is still 0. It doesn't affect that one. And see on this point, 4, 2. So if I stick a 2 in here, right? If I stick a 2 up here, 2 times 2 is 4. Square root of 4 is 2. So that is how you get the compression from the 2, and it graphs like that. At a half, it's going to stretch by a factor of 2. Okay, so by the same thing, 1, 1 will become 2, 1, because you stick a 2 in here for x, and 1/2 times 2 is 1. Square root of 1 is 1. 0, 0 is not affected because 1/2 times 0 is still 0. And for 2, if you stick an 8 in up here, 8 times a half is 4. Square root of 4 is 2. And then you see the way that graph looks. It is kind of it's stretched. It's like it's stretched out horizontally. Okay. Now, there's a few different ways to think about this. The one sort of extra trick here to these is being very careful when more than one of them happen in the same one. It kind of follows the order of operations. The first two here are the horizontal. That's the ones that are inside the parentheses, right? Inside comes first. And then we have these two are outside. I mean, it doesn't really completely follow the normal rules. So really, if you want everything to work out one step at a time, you can do them in this direction. Or actually, for me, when I get several of them happen at once, I just plot a few individual points, knowing the basic shape is going to stay the same. So if there's like a vertex or something in it, or high points or low points, I'll plot those. And then, so like maybe the thing stretches out by a factor of 2 and then shifts right and up. So anyway, I'll just plot the individual points, and then once I have that graphed out, then we'll do it. If it's only 1 or 2, then you can use the transformation rules we have talked about. All right, so here's the same slide with a little more information here over to the right, hopefully an example. All right, so let's try this. We'll go through this. So f of x here is square root of -4 minus x. So we have two things going on. We've subtracted 4, and we've also got this minus on the inside, right? So the subtraction by 4 should be a horizontal. All the changes are on the inside, right? So these are all horizontal changes. So this is a -4, so that's a 4 to the right, and then a minus is going to mean a horizontal reflection. Okay. So there's the original. There's 4 to the right. All right. And then put in the reflection. Now we get that. Okay.